All right, matriculants. This is the second one in geometry. We are looking at the converse of theorem 1, that is the reverse of the first theorem. The first theorem that we dealt with in the previous lesson was saying a line drawn parallel to one side of a triangle divides the other two sides in proportion. So for that one, we were given a line which is parallel. And if that line was parallel, then it was confirming that the two sides are divided in proportion. Now, this is kind of the reverse now. For this one, it is saying if a line divides, if the line divides the two triangles proportionality, then this is the conclusion. That line is parallel to the third side. So this time we are given lines which are in proportion, and the conclusion is this. The conclusion is the line is parallel to the third side. That is the converse of the theorem 1. So if it is confirmed that AP over PB is equal to AQ over QC, then the conclusion is PQ is parallel to BC. And the reason for this, we have only one reason for this, but the previous one we had two reasons that you could give. But for this one, the reason is line divides two sides of triangle in proportion. That is the reason for this one. Line divides two sides of triangle in proportion. Remember, this can be given in 6 different ways. This one is AP over PB. You could just turn it upside down and have PB over AP is equal to QC over AQ. You could also have those other combinations like AP over, that is AP here, that is over the whole side AB, that is equal to this smaller side AQ over the whole side AC. And you can turn this upside down to be AB over AP is equal to AC over AQ. The theorem still holds for that one also. And then you also could have, using these ones down here, we have PQ, we have PB over PB, that is the smaller one, over the big one, AB, that is equal to the smaller one, QC over the whole side there, that is AC. Oh, there we are. We can also turn it upside down. The theorem still holds that the conclusion is these two lines are parallel to each other. Now let's look at questions, how we can use this proportionality theorem. How we can use the proportionality theorem, the converse of the proportionality theorem, to prove that sides are parallel. In this case, required to prove, we are required to prove that RS is parallel to PQ. That is in both of these questions. All right, let's look at what we have. We have the smaller side given compared to the longer side. So here we can say, in our proof here, we are supposed to simplify each side separately, just like we did in trigonometry when we were doing identities. So we are saying PA here over, that is PA over RA. PA over RA, here we have 64 over 104. Right, I need my calculator there to quicken things. There it is. All right, so we are saying 64 over 104, and this is giving me 8 over 13. 8 over 13. Now the other side, the other side is QA over, that is this one, over the whole side SA. Over SA, this is giving me 56 over 91. This gives me what? My calculator once again. 56 over 91 is also giving me 8 over 13 over 13. So we can see that PA over RA is equal to QA over SA, and both of them are equal to 8 over 13. So we can see that the sides are being divided in proportion. What is the conclusion? Therefore, because the sides are being divided in proportion, we can conclude that RS is parallel to PQ. That is, RS here is parallel to PQ. This line is dividing the two sides in proportion, so the conclusion is this line is parallel to the third side. And our reason there, line divides two sides of triangle in proportion. That is the reason there. That is the first question. Let's go to the second one. Yeah, now the second one. Okay, this one is a little bit more interesting than the previous one. We are supposed to prove that PQ is parallel to RS, but we do not have the ratios there. We can get them from this side and that side because we are told that these two lines are in proportion. So we are making use of the first part of the proportionality theorem to prove the parallel lines, to prove that these two lines are parallel. Let's use the previous theorem. That previous theorem was saying if the lines are parallel, then they divide the two sides in proportion. Okay, so we are saying here AB over BC is equal to AP over PR, and that is equal to 12 over 9. Let's simplify this. We can divide by 3 to get 4 over 3. And our reason here is proportionality theorem with BP being parallel to CR. Remember, when you give this reason, you have to give us the line which are parallel there, which are creating the proportionality. Now we are coming from the right going to the left, making use of this one to get the ratio for this side. So we are saying AD over DE is equal to a Q over QS, and this is equal to 8n over 6n. These will cancel, divide by 2, both of these, we have a 4 over 3. Now we can see that for this one we got 4 over 3, for this one we got 4 over 3. So we can say this over that is equal to this over that because they have the same ratio. So our conclusion here, therefore, a P over PR there is equal to a Q over QS, and that is equal to 4 over 3. We got it from the left and from the right. Now that we can see that this line is dividing this side and that side in proportion, the conclusion therefore is that line PQ is parallel to the third side RS. And our reason, line divides two sides of triangle in proportion. That has been confirmed there. All right, let's go to the another question. This should be the last question there. In the sketch alongside, AE as to EC is equal to 2 over 5. I like writing it this way. AE over EC is equal to 2 over 5. Remember, this is just the same. And then BC is 49 meters and DF is 10 meters. There is our BC, the whole side, and this is our 10 meters. And it is given that AD is parallel to EF. This is AD parallel to EF. This is what we are supposed to prove, that AB is parallel to DE. How are we going to do that? All right. I'm seeing two triangles here, and we can separate these two triangles. The first one, this is the first triangle, and then it goes like this, and then it goes like this, and this is, we have a line here that is F, we have E, and we have, this is A, and then we have G. This is what we have, and it's confirmed already that these two lines are parallel. That is given, and we have a C here, and this is 10 meters. And from here, we are told that AE over EC is 2 over 5. So this is AE, EC, so the ratio is here, 2s to 5 there. And because these are parallel lines, because of proportionality theorem, we can actually conclude that this is 2x as to 5x, right? This is because of the proportionality theorem. Let's write it down. We have to write it down. We are seeing that A E over EC is equal to DF over FC, and that is equal to 2 over 5, and is proportionality theorem with AD being parallel to EF. That is what we have there. And now, this is the first triangle, and then let me draw the second triangle there. The second triangle is something like this, and then it goes, and then we have our C here, we have our E, and then we have our, this is D, B, and this is A, this is E. And we are required to prove that AB here is parallel to DE. Now, for us to be able to prove that, we need the ratio for this side. We already have this ratio. This is 2s to 5 there. Let me write it using a different color so that we can see it clearly. This is 2s to 5. But we do not have the ratio for BD as to DC there. We do not have. We can make use of this triangle here, because we are already told that this whole side is 49 meters. And then we have an F somewhere here. This is F here, and if that is F, then here we have 10 meters, right? All right. This is 10 meters here. We do not know this one, but we have FC. We can get FC from this triangle here, right? Let's make use of what we have in this triangle to get FC. This DF is 2x, which is equal to 10m. We can get this value of x and then use the x to get FC here. So we are saying 2x is equal to 10. So your x there is equal to divide both sides by 2. Your x is equal to 5. So we can conclude that your FC is equal to 5x, which is equal to, this is a 2 there, so we get 10, right? We get 10. No. That's a mistake there. Our x is equal to 5, so this is 5 times a 5, so this is 25 meters. So this one is 25 meters. We can also write this as 25 meters. Now, this is 10 meters, this is 25 meters. We need to calculate this one. Your BD there is equal to, remember this whole side is 49 meters, so you can just subtract this 10 and 25 from 49 to get this 10 and 25, that's 35. So this is 49 minus 35. The 35 is from 10 and 25. This is going to be equal to we have 5 plus 9, that is equal to 14. So we are saying this is 14 meters. Now we have everything in our triangle that we can use to prove that AB is parallel to parallel to ED. Let me clear some space here. There we are. All right. This is the color that I want. All right. So we are now saying the ratio here, AE over EC is equal to 2 over 5. We have that. We want the ratio for this side. So we want the ratio for BD over DF. Because here we are saying AE over EC, so we also have to say BD over DF. And that we have seen it to be, BD is 14 meters, and then DF is 10 plus 5, that is 35. And then reduce this one, divide by 7 here, we get a 2, divide by 7, we get a 5. Now you see that this side is equal to 2 over 5, and this side is 2 over 5 also. So therefore, AE over EC is equal to BD over DF, and that is equal to 2 over 5. The two sides are being divided in proportion by this side DE. What is the conclusion? The conclusion is that ED is parallel to AB. So we are saying, therefore, your AB is parallel to DE. That is what we were required to prove here. And our reason, line divides size of triangle in proportion. All right. Please go through the video, watch it and watch it and watch it again. Try to make sure that you fully understand the concept of proportionality, both sides. The first one, where you are given a parallel line that divides line in proportion, and where you are given sides in proportion which confirm that two lines are parallel. All right, that's all I have for you now.